Welcome everyone to my presentation, Reining in the Web's Inconsistencies with Site Policy. My name is Tobias and this is joint work with Stefano, Dennis, Marius and Ben. As you all know, we use web applications to perform various tasks in our daily lives. We share pictures with our friends, participate in online conferences, or look at funny cat videos. Due to this fact, the browser starts to mediate more and more personal and sensitive data. Obviously, this data and the applications using the data need to be protected. Commonly, this is done by security measures that are specified by the server but enforced on the client by the browser. One example could be a content security policy. The way it works is that the server sends within an HTTP response a security header which tells the client which policy should be enforced. So if we visit a web page, in the HTTP response there could be a content security policy or any other security measure which tells the client which security policies apply to the very page that we visit. This leads to the problem, or might lead to a problem, that different security guarantees are used on different pages on the same origin or within the same security boundary. So for example, you visit page A with a quite secure security policy, and then on page B you will find a different security policy that is not secure at all. Let me give you an example. Think about content security policies. We visit the site foo.com/news, which uses a quite strict content security policy, script SRC self, which tells the browser that only scripts should be loaded that are hosted on foo.com. Another page on the origin foo.com/banking, uses a slightly different content security policies and also allows script code loaded from trusted.com. Maybe this page simply needs third-party code to perform some banking use cases. However, on a third page on foo.com/sports, there's a quite insecure content security policy which allows unsafe inlined JavaScript. So the adversary could inject malicious JavaScript code into the site. The consequence is, while /news and /banking are protected, but /sports is not protected, the entire origin risks that it might be attacked by a cross-site scripting XSS attack. Another example I want to highlight are cookies. Think about a cookie which is called key with the value secret, which is set on foo.com/news with a flags secure and HTTP only, which means that it cannot be accessed from JavaScript and is only transmitted via secure HTTPS connections. However, on the banking page, for whatever reason, the same cookie is set, again, key with the value secret, but only the secure flag is set. Maybe the developer needs to access this cookie on this very page to perform some task. Yet on /sports, no security flag is used at all, and the cookie key with the value secret is stored in the cookie jar. This example highlights that depending on the page that the user visited last, a different cookie is stored or different security flags are stored in the cookie jar. If the user visited /news last, then 2 security flags are set, while if /sports is visited last, no security flag is set at all. These 2 examples highlighted that a problem could exist if security attributes are used inconsistently. But how can we find them? In the paper, we present a formal framework that helps us to formally define at which point an object is not secured consistently. But due to brevity, I just want to point out the highlights that we will use throughout the presentation. But I invite you to read the paper if you are interested in this framework. So in this talk, we will only consider cookies and content security policies, but in the paper you will find also analysis for HSTS. So what's the problem, or what could be a problem with cookies? cookies are protected against various attacks by 3 different security flags. Using our framework and for brevity now, we say that cookies are protected inconsistently if different pages assign different sets of security attributes to one cookie. Just remember the last example that I gave you. We visit 3 different pages and each page uses different security flags or security attributes for the same cookie. In this case, we consider it to be protected inconsistently. For content security policies, it is pretty straightforward. In a nutshell, we call a content security policy safe if it mitigates HSTS attacks. Again, in the paper, you will find a more formal definition which relies on previous work. But for now, let's just consider this very simple definition. And again, inconsistencies exist if at least one page on an origin uses an unsafe content security policy. In example, if we find one page that allows an XSS attack, for example, by defining the or by using the unsafe inline keyword or by not using a content security policy at all, we say the entire origin is inconsistently protected. Now, while we have this definition, one could wonder, do they really exist in the wild, or is this maybe just something that we came up with? And to prove or to dive into this, we performed a web measurement, which is probably a quite natural way to understand if this really exists. And what we did is also quite straightforward. We visited the top 15,000 Tranco websites. On each site, we visited several sub-pages. So we visited the landing page of each site, and then starting from there, we crawled several sub-pages of each site, which resulted that we visited more than 30 million pages on roughly 50,000 domain origins. And what we did is we logged all the HTTP traffic and looked into each HTTP response, which security measures are used or which security policies are enforced, and just cross-compared them across the site or the origin. So if we have 10 pages for the same origin, we looked, in case of content security policy, which content security policy is enforced on each page, and then we could compare if they are enforced consistently. So what did we find? Overall, in case of cookie inconsistencies, we found that 9% of all sites are affected. So that means that 9% of all sites set at least one cookie that is inconsistently protected. However, only 4% of all cookies are affected. So we have a quite large amount of sites, or at least a non-negligible amount of sites that is affected. But the overall amount of cookies is not that big. What we also found is that domain cookies are inconsistently protected slightly more often than host-only cookies, but this can be considered as minor. In case of CSPs, we found more troubling results. Almost half of all origins that used content security policies are affected by inconsistencies. So almost half of all origins that try to protect themselves against cross-site scripting attacks with CSPs don't really do it because they deploy them inconsistently. Note again that we consider content security policy inconsistently not if 2 different content security policies exist, and only that if one of these allow cross-site scripting attacks. So different whitelists do not account for inconsistency in our model. The key problem that we identified is that most pages just lack the content security policy header. So in 81% of all cases, the inconsistencies came from missing headers, so that some pages on an origin simply lack the header. In some cases, insecure CSPs were deployed and they included the unsafe inline keyword. Now, when we identified this problem, we are wondering, like, how can users protect themselves, or how can website or service providers account for the problem? And we looked at origin policy, which is currently, so what we're wondering was current approaches help to fix this challenge. And what we did is we looked at origin policy, which is a W3C standard, which helps to enforce secure policies on an origin. So similar to current approaches, the origin policy is defined in an HTTP header, and the HTTP header tells the loaded page which policy should be used. So the service provider then defines at a well-known location one policy that is enforced at a time. So there will be only one security policy. So what's the limitation of this approach? There's only a single policy support. So while if we ignore like caching and stuff like that, there can only be one single policy that is enforced. Our experiments have shown that this will not help in the real world. So there are sites that use multiple secure policies, and they cannot easily adopt this origin policy thing. Another problem, which is by design, is that cross-origin inconsistencies cannot be addressed because, as the name suggests, they only apply to a single origin. However, there are resources that should be protected across origin for the entire site. So, for example, cookies or HSTS. Also, origin policies has implicit security exceptions. So, if one page, for whichever reason, should not be protected or needs different protection, this is done implicitly by simply omitting the header. So it could be hard for a service provider to understand if he misses the header on some sites or, So what's the general problem? Our measurement has shown that according to the security standards, different applications operate under the same origin or site. So we have one origin, but we have different applications which have by design or by nature different security needs. And origin policy simply cannot address this because if we have different security needs on the same origin and we only can define one policy, either the policy is too strict which would not allow all applications to work, or it could be, or it would not be sufficient secure. How could a solution look like? We need a mechanism that governs basic security guarantees at a central location, similar to origin policies, and which guarantees consistent usage of a security policy. So what we do is we propose a site policy, which has three different key differences to origin policies. On the one hand, site policies allows multiple policy support. So again, we have a central location where the site policy is stored, but the site policy can contain multiple policies and each page has to select at least one. So there's one default policy that is always enforced if the page does not specify one, and otherwise the page can choose from different policies. Site policy, as the name now suggests, supports site-wide policies. So for example, if we want to protect cookies or use HSTS or other site-wide measures, we can define them. And there are only explicit security exceptions, which means if someone needs to change the security guarantees of a page, it has to be done explicitly because he cannot simply lack the header, because the default policy will be enforced. So what did we learn? Inconsistent usage of different security mechanisms exist in the field, which means popular sites are affected, so like Google Docs. And current approaches cannot be successfully applied to solve these issues. We propose a site policy to fix all these inconsistencies that we defined and encountered in the wild. And we finally develop a tool chain that helps developers now and maybe in the future to find inconsistencies in their own applications. So I would like to invite you to check out the source code and the tool chain, which you can use to find inconsistencies on your own page. This is my time, and I'm happy to take your questions.